The best fit alignment feature enables the creation of an alignment that follows the most logical path through a series of feature lines, COGO points, AutoCAD elements such as lines, arcs, points, or blocks. From our project, points along the edges of pavement of the existing main road were collected in the field by our survey crew. These points will be used to recreate the existing main road alignment geometry using the best fit alignment command. The alignment that is created will provide a best fit path that splits the path that runs through each individual path of points. The drawing contains COGO points that follow the center line of the existing road for our project, as well as other existing alignments that are impacted by this project. The resulting alignment follows the most logical path through the points collected by our survey team and will be used as we progress into corridor design. When improving or rehabilitating a roadway, one of the first steps in the process is to recreate the existing centerline data collected by the surveyor. Create an alignment from an existing alignment. Our proposed side road alignment will tie into the existing side road alignment on the north end. We will use a portion of the existing side road alignment as a starting point for the proposed side road alignment. Since only the entry tangent of the existing alignment is used in defining the proposed alignment, a start location station was specified. Alignment sub-entities could also have been used. It is important to note that by default, the station values of the new alignment matches the station values of the source alignment. The ability to extract a portion of source alignment to be used as a baseline to create a secondary alignment streamlines the design process, especially on rehabilitation projects, helping to minimize the errors associated with geometry recreation. Automatic curve widening and offset transitions. New widening features have been added to offset alignments. Automatic widening can be added based on new design standards specified in the design criteria file, or manually by selecting numeric values. These features give you the ability to automatically incorporate swept path calculations for offset alignments. Due to the high volumes of trucks that travel through our project corridor, widening through curves is required. The standards used by our local agency specify that only the inside lane be widened. These offset alignments will be used as targets when the corridor model is created. As many parts of the world require roadway widening and curve sections to provide for safer conditions, this tool provides an automated method that can compute the necessary widening based on local rules and standards. Station equation IDs and labels. The station equation ID property is necessary to identify stationing along alignments where there are duplicate stations due to station equation assignments. The new label property indicates which station equations a specific station value is associated with. This new property is available for different types of labels, including those associated with alignments, profiles, sections, intersections, and quantity takeoff. A station equation will be added to the proposed side road alignment at a location where the existing side road alignment and the proposed side road alignment split. The station ID property enables further automation when creating necessary construction documents. Manual editing of station values that fall after the first station equation is no longer required, saving time and keeping documentation synchronized with design changes. Extending profile tangents to a PVI. In order to minimize earthwork quantities, the proposed profile should closely follow the existing ground when possible. A common practice among highway designers is to use the plan elevations to compute tangents for proposed profiles. Once these short tangents have been created, the vertical intersection point must be computed to generate a continuous profile. To store the short tangents along our existing profile, basic AutoCAD line commands will be used with the Civil 3D Transparent command that extracts elevations from the plan view. An AutoCAD line now appears in the profile view. You can see that this line closely follows the existing terrain in the area. To make it easier to work with, the proposed profile will hide the surface profile. The ability to extend the profile tangents to compute the PVI provides a simplified way for the roadway design team to create a design profile that more closely follows the existing terrain. More robust profile alignment, and alignment locking mechanisms have been added to Civil 3D 2011 for improved station locking behavior. Now, design points such as design speed and station equation locations remain in relative geometric position when edits are made. In past releases, these locations would move to a new station location, losing their geometric relevance. To demonstrate this, the start of the alignment will be grip edited and stretched to the east. A point has been stored at the station equation location near the start of alignment for reference. Note that the station equation is no longer tied to the stationing of the original alignment. The location of the equation does not change because it is locked to a geometric location which does not change. Consider the relationship between the alignment and the layout profile. Prior to Civil 3D 2011, the first segment of the profile would have moved to the new start station, thus shifting the entire profile to the left. Now the start station of the profile is an updated station value based on the alignments in the original start location. Expanded dynamic object relationships result in less laborious edits being needed to adjust related elements when changes are made.